Okay, hello everyone. So we'll continue with the paper 3 discussion. So that is the question number 8. Okay, just start. A small particle of mass m moves such that its potential energy is equal to half mr square omega square. Assuming Bohr model of quantization of angular momentum and circular orbit, so radius of the nth orbit is proportional to what? So first we have to look at, so if a particle is in a circular motion and if it is a uniform circular motion, and there will be a force, that is the centripetal force, and centripetal force will be provided by provided by some other force. So now we have to look at, so this is the potential energy. Using this, okay, we can easily look at what is the conservative force that is acting on this particular one. So what's the equation for the conservative force? That is minus of du upon dx, that is a differentiation of u with respect to the x, and here they have given in terms of the radius, so we just take it as with respect to the r we'll be differentiating. So if that is the case, what do you get? If you are differentiating this, half m r square omega square, m omega square is a constant, so r square you differentiate, so that we get it as 2 into r, 2 will get cancelled, so we have it as m r omega square. So that is actually the centripetal force, okay, that is acting towards the center. So therefore we have this. And next what we have to look at, we have to assume that, okay, quantization of the angular momentum. So what's the equation for that? So L equals to nh by 2 pi. So if that is the case, what's the equation for the L in terms of angular velocity? So that we have to write. So first we'll write, that is m into v into r. Okay, so we know it. So v equals to what? V equals to r omega, and as a result, so what do you get? So if that is the case, so we can write this as, so m omega square multiplied by, okay, multiplied by the, okay, wait, so v equals to what? So v equals to r omega. So as a result, so what do you get? So that is m r square omega. So that is equals to nh by, okay, 2 pi. And as a result, so what's the equation for the r? R square is directly proportional root of the n. So that is the first option is the right answer. Okay, so now we look at into the next question, that is mass numbers of the elements A, B, C, D are, so 30, 60, 90 and 120. Okay, specific binding energy of them are given as, so 5, 8.5, 8 and 7 MeV respectively. So then which of the following reaction energy is released? So first we have to, okay, remember this, when the energy releases, if the specific binding energy of the product is greater than, okay, if the total binding energy of the product is greater than the reactant, so then we observe that there is a, okay, release of energy. So for that case, what we'll do is, for every reaction we just try to find out what is the total binding energy for the reactant and also for the case of the product. So for a first equation, so that is D equals, okay, D changes to 2 into B. So what is the binding energy of this particular one? D has okay, specific binding energy, that is 7. So okay, total number of nucleons are 120. So 120 into, okay, 7. So that is 120 into 7 is the total binding energy of the D. Okay, and then, so what is the total binding energy of the, okay, the product here? So B, what we have, so B is, so okay, it is 8.5, 8.5 multiplied by the 60. So that is 8.5, so multiplied by the, okay, 60. So if you just do the calculations here, okay, this 8.5 multiplied by the 60, so we get it as, okay, somewhere, okay, the value I just write it here. So this we get it as, so 10, okay, 20, and we also have to multiply by the 2 here. So 1020 we get it. So 120 into 7, so that will be 840. Okay, as a result, so total, okay, binding energy of the product is greater than this, and as a result, so we can say that this is a possible, okay, reaction. And in the next case, okay, that is a C becomes, okay, C changes to, okay, B plus A. See for a C, what, say again we have to look at in the same way. So you can just, okay, do that particular one, and as a result, so we observe that only for a D, okay, we get it as the right one. So that is option A is the right answer. So what you have to do is, so for every equation, so we have to find the binding energy. So binding energy of the C is what? So that is, okay, C has 90, so 90 multiplied by the 8, and again for a B and the E, you have to calculate and you have to cross check. Okay, fine. Okay, next. A stone weighing 3 kg falls from a top of a tower of 100 meter high and buries itself 3 meter deep in the sand. The time of penetration is. So now we just try to look at, so let us say here we have a sand and a body is released, okay, from a height h, so that is the 100 meter, and whenever the stone is enters this, so it has some velocity, let us say that is a u, and it passes, okay, so it moves 3 meter deep in the sand. So if it moves a 3 meter deep in the sand, and final velocity will be, okay, 0, we know it. So in that particular case, what is the time taken, so to move from the surface to that particular point? So how can we write this particular one? Okay, we can use the, okay, first equation of motion. So what is that? V equals to u plus at. V is 0 and acceleration is opposite direction, so therefore t we can write as it is a u divided by the a. Okay, so first what we have to find out, we have to find the acceleration, and also we have to find the initial velocity at this particular point. So because it is dropped from a certain height h, so what is the velocity we can write? So velocity we can write as it is a root of 2gh. Okay, so that is the velocity at this particular point. And what is the acceleration, okay, inside the sand, inside the sand medium? So again we have to take the third equation of motion and we have to write that acceleration. So acceleration I can write this as, so a is equals to what? So that is the, okay, v square divided by the, okay, 2s. Okay, if it is v square by the 2s, so what's the equation for the v? We know it. So that is the, okay, so that is root of 2gh square, root of 2gh square divided by the, okay, 2s. Okay, when you simplify this, so what do you get? So t equals to what? Okay, t equals, see, without this also we can do it. So that is u divided by the a, u square divided by the 2s. Okay, we can cancel this. Okay, I'll just write it as u divided by a, so divided by u square divided by the 2s. Okay, 1 u, okay, will get cancelled, so we are left with the 2s divided by the u. Okay, okay, yes, we know it. So what is a u? U is the root of 2gh, so therefore t equals to 2s divided by root of, okay, 2gh. Okay, substitute all the values, okay, in this particular one, so we'll get the right answer here. So what is the value of the s here? Value of the s is the 3, okay, g is 10, okay, you take it, so h is also, okay, 100 meter, okay, if you just substitute that, so we'll get the answer as the b, that is 0.13 second. So you have to do the substitution part, okay, I'm just leaving that substitution part for you. Okay, substitute s, g, h, and you'll get the equation or value of the time. Okay, fine, next one. So in the middle of the depletion layer of the reverse biased p-n junction, okay, what happens, or which statement is the right answer? So in the case of the reverse biased p-n junction, so what happens, the depletion layer increases. As a consequence, when the depletion layer increases, okay, so let us say depletion layer, so it is the p type, let us say it is the n type, okay, depletion width, okay, width increases. At this particular part, so what we observe that at the boundary of the depletion, okay, layer, so we observe that electric field is maximum, and at this particular central point, so what we observe, the potential, okay, potential becomes maximum at the center. So if the potential is maximum and it is a constant, so potential is maximum here and electric field is, okay, maximum at the edge. So if the potential is maximum at the center, so what happens to the electric field? So electric field is the okay, change in the potential with respect to the distance. So therefore at this particular point, so electric field becomes, okay, 0 at the center, and at the edge it becomes a maximum. So therefore, so that is the option A. So what is asked is at the center, okay, so therefore it is electric field is 0. So fine. A car moves from x to y, okay, x to y with the speed, let us say, okay, x to y with the speed, let us say that is a vu, and returns from, okay, returns from y to x with the speed, let us say that is a vd. The average speed of this particular round trip is, okay, so here, okay, distance between the x and the y is a constant, okay, in that particular case, what is the v average? We can write it as, so v average is the, okay, so in this particular case, so actually we are looking for a speed here. So if that is the case, so total distance traveled, so 2s, okay, divided by the total time. So we don't know the time here, so we have to write in terms of the velocity here. So generally how do you write the speed? So that is the distance divided by the time. So therefore time we can write it as what? So d divided by the, okay, speed or the velocity. So therefore for a first one, what we can write? For a first one, that is s divided by, okay, vu, okay, plus S divided by, okay, VD. So yes, I can take it as a common, I can cancel that. So finally what we can write, so 2 VU, okay, VD divided by, okay, VU plus, okay, VD. So that is our right answer. So that is the option D. Okay, next, a series combination of N1 capacitors, each of the value C1. So you should remember this, okay, N1 capacitors of value C1 is charged by a source of potential, so that is the 4V. When another parallel combination of N2 capacitors, okay, of value C2 is charged by a source of potential difference V, okay, has what? It has a, okay, same energy in it. The first okay, the value of the C2 in terms of C1 is what? See, what is the condition here? Condition is, okay, energy remains the same. What is the equation for the energy? We know it. So that is, let us say, just write as E1 equals to E2. So what is the equation for energy? Half CV square. Okay, half CV square. Okay, V we know it. Okay, so we know that it is a 4V. So I'll just write it as 16V square. What is the effective capacitance in the first case? Okay, N1 capacitors are in series. Okay, so therefore we can write as C divided by the N. Okay, that is equals to E2. So E2 is what? Again we can write half, okay, C effective multiplied by the V square. What is the C effective here? It is parallel combination, so therefore it is a N into C2. So this half we can cancel this, okay, and V square also we can cancel this, okay, as a result. So C1 equals to, okay, here we have to write, let us say that is a C2 equals to, okay, C2 equals to what? Okay, let us say it here, it is N1 and here they have given it as N2. Okay, C2 equals to 16C divided by N1 N2. Okay, therefore that is the option D is the right answer. Okay, next, a positively charged particle moving towards the east enters a region of uniform magnetic field directed vertically upward. So something like this. So magnetic field is in upward direction. So let us take this as the east direction. And what is the angle between them? Angle between them will be 90 degree. The particle will, okay, so what happens to the particle? So because the angle is 90 degree, okay, it will be moving along the circular path. So we have to look at the which one is right answer here. So whenever it is moving in a circular path, we have to keep it in mind that, so magnitude of the velocity, that is a constant, so that does not increase or decrease. Okay, so therefore what we can say here, move in a circular path with the uniform speed, so that is the right answer. Next, in a circuit of LCR connected in series with the alternating voltage source of frequency nu, the current leads the voltage by 45 degree. If the current leads the voltage by 45 degree, what is the value of the C? So what is the equation for this? So okay, what is this particular one? So here this value represents the phase difference. So we know the equation for the, okay, phase, that is the tan phi equals to what? Okay, tan phi equals to, so here the angle is 45 degree. So because tan 45 we can take it as the 1, and we also know the equation. So in general, so we write it as XL minus XC divided by R, or XC minus XL divided by the R. So here which one we have to use here? That is current leads the voltage. If the current leads the voltage, so we have to take it as XC minus the XL, okay, divided by the R. So now we have to simplify this and we have to get an equation for the C. What is the equation for XC? We know it. So XC is, okay, this XC is 1 by omega C and XL is omega L. So therefore I can write as 1 by omega C minus omega L, and I will cross multiply, so that becomes the R. So therefore, so if I just transfer this, so we will get it as R plus omega L, so that is equals to 1 by omega C, and as a result, what is the C then? Okay, C will be 1 divided by omega, okay, R plus omega L. So what is omega in general? We know it. So omega we write it as this 2 pi f. So if we just substitute 2 pi f into R plus 2 pi f into L, okay, 2 pi f into L. So therefore, okay, therefore, so that is the last option is the right answer. Okay, next, for the electrical circuit shown in the figure, which of the following equation is correct? Say for this particular circuit, so we have to write the, okay, equation using the second law. So that is, you can take a loop. So that, okay, now I'll take it as, let us say this is the first loop, and this one you can take it as the second loop. So here if you just look at this particular point, so at this junction, so what happens here? Current enters here, here also current enters, and what is the current passing through this upper branch? So current passing through the upper branch is I1 plus I2. And again, what is the current passing through this? Current passing through this will be just the I1. And if you look at this, what is the equation it becomes then? So equation becomes for the first one, so that is the, okay, so we can write it as, so here because we are moving in this particular direction, so from lower potential to the higher potential we take it as a positive, okay, minus along the direction we take it as negative, so therefore it is a I1 plus I2 multiplied by the capital R minus, okay, here we can write it as it is a I1 R1 that is equals to 0. Okay, so just look at all the equations. Do we have any equation, okay, similar to this? So if you look at this, okay, the last last one is the right answer. Next, a thin circular ring of mass m, I'll just write this, a thin circular ring of mass m, okay, radius is r, rotating about its axis with a constant angular velocity. Its axis means this particular one, it is, okay, rotating with the angular velocity omega. 4 objects each of mass m are kept gently to the opposite ends of 2 perpendicular diameters. So it is the one diameter we can take, another perpendicular diameter is this particular one, and here actually we are placing the, okay, small, okay, let us say m. Okay, then what is the angular velocity of the ring will be? So what is the concept we have to use here? Whenever it is just gently, okay, kept on this particular one, total angular momentum of that particular system, that is a constant. So how can we write? That is L1 equals to L2. I can write as I1 omega 1 that is equals to I2 omega 2. So here what we have to look at for a ring. So let us say this is the initial case. So I1 we can take it as it is only for a ring. So because it is a ring, it is just we write it as it is mr square. And for a case of the I2, what happens? Okay, for a case of the I2, we have a ring, and along with that we have the 4 particles. They are at a distance what? At a distance r from the axis. So therefore I can write as it is a 4 m r square. Okay, so that is I1 and I2 we know it. Omega 1 we just take it as omega, and what is the omega 2? So what is omega 2 from this particular equation? So that is I1 by I2 multiplied by the omega 1. So what is I1 here? That is a mr square divided by, okay, m plus 4m r square. So this r square will get cancelled and multiplied by the omega. Okay, so therefore, okay, therefore option B is the right answer. Okay, so look at a block of mass m is in contact with the cart C as shown in the figure. The coefficient of static friction, so what is given here? Static friction is given, that is a mu. Acceleration of the A of the cart will prevent the block from falling. So look at this particular part, whatever we have, it has a block, has a mass m, okay, it is under acceleration A. So one thing you have to keep it in mind, whenever there is an accelerated, okay, system in a, okay, non-inertial frame, what we observe, so there is a pseudo force that is actually acting in this particular direction, that is the ma, and this itself we take it as the, okay, normal force. Okay, if that is the case, because this is the area, okay, the point of contact, and generally we know that mg is that is acting in the downward direction. Okay, as a result, so here we will be having the opposition, so that is the static friction that is in the opposite direction. Okay, we will be writing these equations. Okay, for a maximum friction we can write as it is a mu times the m into the a. If the block is not not falling downward, so that implies what? Okay, that implies, okay, mu ma, that is equals to mg, or m will get cancelled. So what is the acceleration? So this particular one is generally it will be greater than or equals to, and therefore we can write as acceleration is greater than or equals to, so g divided by the mu. So therefore, okay, so therefore it is the option C is the right answer. Okay, so next, so there are 2 sources of light, each emitting with a power of 100. So for both the source we have what? So that is a 100 watt power. Okay, power is the same. One emits X-rays of wavelength 1 nanometer. Okay, the other visible light, okay, of 500 nanometer. The ratio of number of photons of X-rays to the number of photons of the visible light will be of this particular ratio. So what is the equation for that? So power remains the same, means whatever the energy released in a given that particular time, that is also the same. So what we can write, E1 equals to E2, and we have lambda here. How can we write the energy in terms of the lambda? Generally we know that hc by lambda, and let us write this way. So that is, first one is the X-ray, so therefore I will just write nx hc by lambda x, that is equals to n visible, so nv hc divided by the lambda of the visible. So therefore hc is a constant, so we can easily cancel that. What actually we want the ratio of nx to nv, so therefore what we can write, nx divided by nv, so we can write as lambda x divided by the lambda y. So lambda x is what? Lambda x is 1 nanometer, lambda y is 500, so therefore it is of the ratio 1:500. Next, which of the following statement is false for the properties of electromagnetic waves? So we have to remember all the properties. So now we'll just look at this way. Both the electric and magnetic field vectors attain maxima and minima at the same place at the same time. So this is a correct statement. So what actually we want to get? We want to get a wrong statement, false statement we have to look at. So we should, how can we explain this particular one? So if this is the electric wave and we can take this as the magnetic wave, at the same instant, so it becomes maximum, at the same instant it becomes zero. So therefore first one is a right statement. And the second one, energy in electromagnetic wave is divided equally between electric and magnetic vectors. So that's why we write that is the average energy density of electric wave, that is equals to the average energy density of the magnetic. That is also correct statement. Next, both electric and magnetic field vectors are parallel to each other and perpendicular to the direction of propagation. So just now I have drawn this. So what is the angle between these two these two waves? That is 90 degree. So it cannot be parallel, it is always perpendicular, therefore it is wrong. These waves do not require any material medium for a propagation, so that is also correct. Fine. So therefore the right answer is what? So right answer is option C, that is the wrong statement. Next, the momentum of a photon of a electromagnetic radiation is given by, P is given 3.3 into 10 power minus 29. What is the frequency of the associated wave? What are the equations we know here? So energy, we know that it is a P multiplied by the C. So what actually we have, that is a P, we want the frequency. Energy, we can also write it as H into the nu. So we can compare this. So as a result, what we can write? So that is H nu is equals to P into the C. Nu equals to PC divided by the H. So you can just substitute and simplify this. So P is 3.3. C multiplied by the C, that will be 9.9. Divided by 6. Here the power becomes what? So 10 power minus 29 into 10 power plus 8. So minus 21. So divided by H. So that is the 10 power minus 34. If you do this particular simplification, so you will get the right answer as that is the 1.5 into 10 power 13. Next, the adjacent diagram shows a charge plus Q held on an insulating support S. So look at this diagram. If it is not clear, I will just redraw it. At this particular point we have the plus Q and it is held by a insulating stud. O represents the center. So this is the center O. So, P is the point such that, so here we have some point P such that OP is X and this is the R. What is an equation for electric field at point P? What is the equation for the electric field? So because it is placed inside a hollow spherical, which type of this particular one? It is a spherical conductor. So this particular one is a conductor. If it is a conductor, what happens? It induces negative charge on the inner surface of that particular one, and outer surface has positive charge. And whenever we take a Gaussian surface, what happens? So total charge inside, so this particular charge, because this negative charge and the positive charge balance each other, therefore this net charge inside becomes 0 and we are concentrating only the positive charge on the surface. So in that particular case, whatever the distance we take, that is the X, not the R. So as a result, so which equation is right? So that is the Q by 4 pi epsilon naught X square will be the right answer. Next, in the given figure, a particle starting from a point 1 traveling up to a B with the speed V, then up to a point C with the speed 2V, Okay, so it is not the 3r, so make a change, so that is a 3v. The average speed, okay, so this is average speed with the entire path is, so what's the, okay, average speed. So what's the equation for the v average? So we know that total distance traveled, so divided by the total time. So what is the total distance traveled here? Okay, total distance traveled is the 2 pi r. I can write it as it is 2 pi r circumference, so divided by the time taken. So how can we write? So okay, already we have solved a similar question, okay, similar type, we have already done it. So what's the equation for the time? So that is the angle, okay, total distance divided by the velocity. So for this, what is the distance here? So distance we take it as, so okay, it is a linear one we are asking, so that is r multiplied by the theta, so divided by the v. That is the general equation, you have to keep it in mind. So r, okay, is the same. What is the theta here? Theta is 90 degree, that is pi by 2, okay, v1. The next, for the second one, so angle is 120 degree. So if it is 120, okay, degree, so what will be the theta then? So it is r divided by v2 multiplied by the theta, so that will be 2 pi by 3, okay, plus, okay, plus what is this, what will be this particular angle here? So this angle is 90 degree, so 120 plus 90 will be 210, okay, 360 minus 210 will be 150 degree. If it is 150 degree, so what we can write? So here it is, we are writing it as r by v3, okay, multiplied by 5 by 6 multiplied by the pi. So you have to just simplify this. So take this pi r as a common, okay, if you take the pi r as a common and if you just simplify this particular one, so you will get the right answer as the 1.8. So to just simplify this, you will get the right answer. Okay, fine. Next, 70 calories of heat are required to rise the temperature of 2 moles of an ideal gas at a constant pressure. So this one you have to keep it in mind, constant pressure from 30 to 35. Amount of heat required to rise the temperature of the same sample of the gas, okay, at a constant volume. So what is given to us? Okay, 70 calorie, that is the Q, okay, the heat energy required, okay, and at the constant pressure. So what is the equation for the Q? We can write it as, so we write it as Cp n into delta T. They have not given the value of the Cp, we have to find out. And what will be the Cp then? So that is a 70 divided by, so number of moles it is a 2, and delta T will be just the 5, so that will be just the 7. If it is 7, in the bracket they have mentioned, so look at this particular one in CGS system, okay, R they have given it as 2 calorie per mole per Kelvin. If Cp is this much, so what is the Cv then? Cv is Cp minus the R, so therefore 7 minus the 2, so we can take it as it is just the 5. If it is 5, what is the heat energy required to, okay, heat energy required equation, that is n Cv delta T. So n we know it, so 2, okay, multiplied by 5, so multiplied by 5, so that will be 50 calories. Okay, fine. Next, okay, the last one, particles of masses 2m and, okay, 2m, m and m are respectively at the point ABC. So just look at this particular diagram, and they have given that AB, the distance AB is half of the distance of, okay, that is BC. The m is very much smaller than the capital M, and at a time t, they are all at rest. So in the beginning they are at rest, at subsequent time before any collision. So which one is the right answer? So here if you just look at this, so here we have to look at the gravitational force acting on this particular one. Gravitational force equation is what? So that is okay, G m1 m2 divided by the r square. And if you are looking at this at the point B, so there are two forces, one is due to the A and another one is due to the C. Okay, this is due to the A, this is due to the C. So which particular force is greater? Let us say this is F1 and F2. And here this particular one is very near to this, and as a consequence, okay, the force will be greater. Okay, and also if you just look at the product 2m into m here, and the mass product is m into m, so therefore, so product m1 and m2 is also greater for this particular pair compared to this. So therefore what we can conclude, so f1 is actually greater than the f2. If f1 is greater than the f2, what we can say, so this m will be moving towards the 2m, so therefore that is the option C. Okay, so this completes the paper 3 discussion. Okay, thank you for this, thank you for watching, and if you like, so please, okay, share and subscribe.